Good morning, juniors. Last week, you guys, let's do this. All right. So today we are going to learn about a new set of identities. They're called the double angle identities. Okay. So, if I were to tell you to find the sine of 90 degrees, remember sine is the y piece, you would hopefully tell me that the sine at 90 degrees is 1. Now, if I were to tell you, well, what's the sine of double that angle? What is the sine at 180? We see that the sine at 180 is 0, but some people think that you could just take that 1, that sine at 90, and double that 1, and that's what the sine would be at 180. But as you can see, that is not true at all. So the double angle identities kind of give us little formulas, little identities that we can use that would tell us what the sine would be or what the cosine would be if we were to double that angle. So I'm going to go ahead and show you what those identities look like, and then we'll talk more about them. So there's one for sine, cosine, and tangent. So here is so the double angle identity for sine looks like this. And you can see how they kind of write it. So the sine of 2 theta, there's 2 angles, 2 thetas. And notice that the 2 is within the argument. And then we have equals 2 times the sine of theta times the cosine of theta. By the way, these would be good things to write down on your trig identity sheet that we started a long time ago. All right. Next ones I'm going to show you are the cosine ones. And notice there's 3 of them, but it's really just manipulating the first one. So the first one's kind of the big one. So we have cosine squared minus sine squared. And I said the other 2 were manipulating the first one. So I'm going to show you kind of how. So let's say I left cosine squared there. But let's say I want to replace that sine squared. Using our Pythagorean identities, another way I could write sine squared is 1 minus cosine squared. So I'm going to go ahead and plug that in for sine squared. And now if I clean this up, distribute my negative, you see we're going to have a plus cosine squared here. So cosine squared plus cosine squared gives us 2 cosine squareds. And then we have the minus 1. So that's how they got that second identity. And then the third one, they would have just gotten by replacing cosine squared by 1 minus sine squared. So like I said, that first one's really the big one. These other 2 are just a play off the Pythagorean identities. All right, and then the tangent one looks like that. So again, I would make sure you pause the video and get all of those written down on your trig identity sheet. All right. And let's see, I think I want to prove to you guys that these work as well. So let's say we're looking at the sine of 45 degrees. So the sine of 45 degrees is square root of 2 over 2. And let's say we want to find the sine at double that. So we want to find the sine at 90 degrees if we double 45. So we're going to go ahead and plug that in. So our formula was 2 times the sine. So 2 times the sine times the cosine. So we're looking at the cosine of 45 degrees as well because our theta was 45. So the cosine of 45 degrees is the square root of 2 over 2 as well. So now let's go ahead and clean this up. I'm going to multiply everything. So 2 times the square root of 2 times the square root of 2 is going to give me 2 square roots of 4. And the square root of 4 we know is 2. So 2 times 2 really gives me 4. And then on the bottom, same thing. 1 times 2 times 2 gives me 4. We know 4 divided by 4 is 1. And if you look at the sine of 90 degrees, what we get if we were to double 45, we can see that it works. The sine is 1 at 90 degrees. So kind of cool. Anyways, that is not quite what we're doing today. So your directions today are going to look like this. So given the sine of some angle, we don't know what the angle is. Given the sine of some angle is negative 7 over 25 on the interval pi to 3 pi over 2. And our directions are to find the sine of 2 theta, cosine of 2 theta, and the tangent of 2 theta. So hopefully you guys kind of remember doing this from way back when we started trig. But the first thing I'm going to start with, I'm going to draw a picture. And the first thing I'm going to start with is that piece right there. So from pi to 3 pi over 2, or if you want to convert that to degrees, we know pi is really 180 degrees, and 3 pi over 2 is really 270 degrees. So on the interval pi to 3 pi over 2, that is this quadrant right there. So I'm going to go ahead and draw a reference triangle and that quadrant right there. And now remember, our theta always goes touching the origin. It's always that angle right there. So that's the one I'm looking at. And if we're dealing with sine, remember sine is opposite over hypotenuse. So sine, I'm going to have my opposite side have a length of 7. And my hypotenuse then has a length of 25. And then we need to go ahead and figure out what our adjacent side is. And since this is a right triangle, I'm going to go ahead and use Pythagorean theorem. So my a squared plus b squared equals c squared. So one of my sides is 7. My hypotenuse is 25. Let's go ahead and clean that up. So it looks like my other side is going to have a length of 24. One more important thing that we got to remember, though, I've kind of ignored it up to this point. Remember, because I'm going left, this side also is going to be negative. And same thing, because I'm going down, this side will also be negative. All right, and now I'm just going to kind of plug these values in to our formulas. So I'll do the sine of 2 theta first. Or 2x, doesn't really matter. So our formula says we do 2 times the sine of our angle. And if we look at the sine, they already told us, but opposite over hypotenuse, we get negative 7 over 25. And then times the cosine of our angle. And we know cosine is adjacent over hypotenuse. So we'll times that by negative 24 over 25. So we drew the picture out, and if we want to find what the sine would be if we were to double this angle, we would do 2 times the sine of this picture times the cosine. And now let's go ahead, and I don't want the answer in decimals or anything. I want it in fractions. So we're going to multiply across the top. Woo! So we'll have 2 times negative 7 times negative 24 gives us 336 on top. And then do the same thing, multiply across the bottom. We have 1 times 25 times 25. We get 625. And I'm okay if you don't reduce them. Just leave them like that. That's fine. 9 times out of 10 you can anyways. Okay? So again, if we were to double this angle, the new sine would be 336 over 625. All right, let's go ahead and do cosine then. And now for today, it does not matter whatsoever what identity you use. You could use any of the three of them. I think I'm just going to use the first one. And there's no rhyme or reason for that. You can use any one you want. So cosine of 2 theta. The formula I'm using says we do our cosine squared. So if I look at my picture, my adjacent over my hypotenuse squared, and then minus sine squared. So minus my opposite over hypotenuse squared. And now let's go ahead and clean this up. I'm going to remember our properties of exponents. We really square the top and the bottom. So I'm going to do that. So negative 24 squared gives us 576. And 25 squared is 625. Same thing over here. I'm going to distribute that square to top and bottom. Negative 7 squared is really 49. And we just found out that 25 squared is 625. All right. Now notice we are subtracting fractions. When we subtract fractions, we need common denominators, which I so nicely already have. So 576 minus 49, the tops, gives us 527. And remember, our denominators stay the same. So if we were to double this angle, the new cosine of that angle would be right there. All right, last one then we need to go ahead and find tangent. And I'm going to go ahead and use the formula, and then I will show you guys a trick as well. All right, so tangent of 2 theta. If we were to double the angle, what would the tangent be? So up top, we have 2 times tangent. And if you look at tangent of this picture, it is opposite over adjacent. So we'd have negative 7 over negative 24. And then we divide all of that by 1 minus tangent squared. So we have 1 minus our tangent, which we found to be 7 over 24 squared. All right, I think I'm going to clean up the top first. So if I multiply across the top, I'm going to get 14 over 24. And divide that, we have 1 minus, again, I'm going to go ahead and square top and bottom. So we're going to get 49 over, 576. Notice this is getting kind of messy. All right, so first thing I need to do before I can divide these two fractions is I need to clean this up. So to get my common denominator, I'm going to times top and bottom of this one by 576. And 576 minus 49 is going to give us 527. So I'm going to rewrite this. So the top we haven't done anything to. And then we know this is really division. I'm going to write this sideways. Division, and then we said 576 minus 49 is 527 divided by 6, or sorry, that'd be 576. What am I doing? So here's the top, and then here's our cleaned up bottom. And now we know that since I wrote this horizontally, we know another way we can write division is really multiplication by the reciprocal. So now let's go ahead and multiply across the top. 14 times 576 is going to give us 8,064. And if we multiply across the bottom, we get this really big number right here. And like I said, for homework, I'm okay with you guys leaving that. I'm going to reduce it right now because I want to show you something. So if I do 8,064 divided by 12,648 and get that to a simplified fraction, we get 336 over 527, okay, for our tangent. All right. That was kind of a complicated process, right? We had to square fractions, we had to get common denominators, we had to multiply by the reciprocal. It was kind of a pain in the biscuit, not gonna lie. All right, I have a trick for you guys, and hopefully you guys have thought of this already. But we know, according to our quotient identities, we know another way we can write tangent is sine divided by cosine. So rather than using this complicated formula that had us do a bunch of extra steps, in order to find the sine of our tangent of double this angle, let's just do the sine divided by the cosine. So we've already figured out what the sine of 2 theta was. That was our first step. And let's go ahead and divide that by the cosine of 2 theta, which again, we've already found. Now again, we know that to divide, we really multiply by the reciprocal. So I'm going to go ahead and change that to multiplication by the reciprocal. And look at that, the 625s are going to cancel. And we are left with 336 over 527, which is exactly what we got when we used the formula. But this was a heck of a lot easier. We didn't have to do any extra steps because we've already figured out what the sine of 2 theta was, and we already figured out what the cosine of 2 theta was as well. So if I were you guys, and this got to be kind of a long video, hopefully you stuck around for my trick. If I were you guys, I would 100% use the fact that we know that tangent is sine divided by cosine. Use those things you've already found to get what your tangent is. All right. Have a good one, you guys.